Sorry, my computer died.
Hey, when it rains, it pours, man. That's the way it goes. It's always something. So just asking if you had gotten the midpoint for me on this.
Sorry. Yeah, it died and then I had to reset it, so I didn't get to starting.
Okay, I'm going to click get rid of that. All right, if you could calculate the midpoint for us.
Okay. Wait, so would 3 plus minus 1 be 2 or -2?
It is positive two, positive two. You look for the one that's further from zero, the three. That's the sign. Then you subtract the numbers. 3 minus 1 is 2.
Okay. So let's see. 1 and 7. Wait.
Yes, good. This is correct. Totally correct. You seem uncertain, and I know your personalities, you're not super assertive, but like you're doing this correctly. So I want you to be a little bit more confident with your answers because you can absolutely do this. This is not, you know, beyond you. All right, let's talk
Ye-
about the distance formula. All right, so I'm just reframing the question here again with, so the distance formula is y2 minus y1 squared plus x2 minus x1 squared square rooted. So I'll sort of help here. Again, it's really good to label the points. That way you know what goes where. 10 minus 4 squared plus -1 minus 3 squared square rooted. So will you subtract and square, do the operation and square, and tell me what you come up with?
So like,
Like do everything but the square root is what I'm asking you to do. We'll talk about the square
oh,
root.
so like 6 and -4.
You're going to square those, you're going to add them together.
Um, for the first one, 36. Second one would be -16.
Isn't it though in parentheses like this?
Yeah.
And so a negative times a negative becomes,
Oh, so +16.
good, okay. Now you got to add them together. Is that okay?
Mm-hmm.
All right. Now, you will learn how to reduce this root, but we're not going to do that today. That will take away from what we're trying to accomplish. So, all right. We're going to do a problem like that one. We're just going to it's going to be set up slightly differently. So here's your next problem for us to look at today. We want to first identify coordinates P and Q. So could you give me the ordered pairs of P and Q, please?
Okay. So P would be negative 4.
All right, the Y coordinate is -4. What about the X coordinate?
Um negative, oh wait. Oh yeah, -3.
Yep. So you first go left or right and then up or down. Give me
Okay.
the coordinates of Q.
Q is 2 and 5.
Good. Right. Did you write the midpoint formula down from before, or do you want me to go grab it?
I didn't write
Okay.
it down.
All right, so I'll write it down here again. When you're doing the calculations, it's really good to write the formula down. That's the only way I've found that it's helpful to remember it.
Okay.
But that is up to you, of course. So they'll be in the notes that I send you at the end. So, all right, go ahead and calculate the midpoint for us, please.
Real quickly though, when writing down this formula, do I need to have the parentheses?
So the midpoint is an ordered pair, and that's what it's like trying to represent here. Like, is this is the first coordinate, this is the second coordinate.
Okay. So for the first one, I have -1/2, and the other one I have just 1/2.
Good. So if we're to put a dot there on the graph, about right there, call that in for the moment, for the midpoint. Does that look to be about the midpoint here, the middle,
Yeah.
roughly? Yeah. Cool. All right, so the next thing we did is the distance formula. So we're going to grab these coordinates again. And distance formula is y2 minus y1 squared plus x2 minus x1 squared, square rooted. I'd like you to do everything but the square root part. Put the
Okay.
numbers in, subtract, square, add, all that. Everything
Let
but
me,
that, please.
I just want to write this down real quick. Okay, I got 106.
Okay, square root of 106. Let's take a look here. So 5 minus a minus 4 squared is 9 squared. That's 81. And then 2 minus a minus 3 is 5 squared, which is 25. You got it. Very good. Okay, so we've done a couple of examples uh, of midpoint and distance formulas. We're gonna look at a kind of a related problem. Uh, yeah, we'll do this one. Okay. All right. JK has endpoints -110 and -5, 2. So I'm going to go out to the internet here and I'm going to find a coordinate plane. So that I can grab. Oh boy, why don't they have one that's labeled already? That's okay. All right, copy. All right, so here we go. All right, so let's graph these here. So -110 is like here, that's J. -5, 2 is there, that's K. If we draw a line there, there's that line. And MN has endpoints 9, -7. So about there, that's M, and 1, -3. It's about there. What does your eye tell you? Do these look congruent to each other?
No,
No?
I mean, not really.
Maybe I've drawn them terribly. They I believe they are congruent, but the
Mhm.
way to know for sure is to find the distance from K to J and the distance from N to M, which is doing the distance formula. So I want you to pick, doesn't matter to me which one, just pick one of these. I'll do the other. Which one do you want to do, from K to J or from M to M?
I guess I'll just do the first one. So
All right,
J and
so
K.
go ahead and calculate the distance formula. I will do the same for this other one here.
Yeah. I got negative 39.
It definitely can't be negative. Remember, you're squaring, whenever you square, you're squaring positives. Or even if it's negative, it becomes positive. So did you write 2 minus 10 squared like that?
Yeah.
Okay, so that's negative 8 parentheses squared plus negative 5 minus a minus 1 squared. What does that become?
Oh, wait. Oh, oops, I accidentally did the numbers for like the one we did before, which was like negative 3 and 2 instead of
Yeah,
uh
go ahead and redo the calculation. We kind of got it all up here.
um, 80.
But more importantly, I want you to just recall you said something like negative 39 or something. Whenever you square, it's always positive. So, worst case is you give me the square root of the wrong number, but it should be always a positive. Now these are the same. So even as poorly as I've drawn it, we can say that they are congruent.
Okay.
Okay, let's look at another problem here. So a lot of geometry is very challenging because you don't get a picture. Before we even attempt to solve this problem, I want you to try to draw what you see. D is the midpoint of CE. They're telling you something about CD. They're telling you something about DE. Forget about this right here. Could you just make some sort of a sketch for number 5 on your paper? It doesn't have to be very accurate. It just needs to be something that is reasonable. You have a picture?
Mm, I'm still drawing it.
Okay. Let's not make like CE is a segment. So like don't make it too complicated. Like you can say that's C, that's E.
Oh, oops, I was making the whole graph.
Yeah, sorry. So what I was trying to avoid just anything too. This is one of the things that doesn't work real well about Zoom, but I can't see what you're doing. But D is the midpoint. There's D. What do we know about the midpoint? What does it do to the segment?
Bisects it.
Yeah, cuts it in half. So C to D is 9x minus 7. B to E is 3x plus 17. You asked for a little algebra review. We know that CD is equal to DE, which means that you can set these equations equal to each other and solve for x. So I'd like you to do that, please. I'd like you to set the equations equal and solve for x.
Okay. Um, wait, I'm kind of struggling on it. Like
Okay, so which side has the smaller x? Is 9x or 3x smaller?
3x.
So you move the smaller to the larger. This is now what's called a two-step equation. We've solved a bunch of these. You undo addition and subtraction before multiplication and division. So you look at the side with the variable, the left side, you don't care about the right, and you undo the addition and subtraction before the multiplication and division. What does that mean here? What are you going to undo?
-7.
By adding 7, yes.
Okay, that's what I got.
Okay, but your x is not by itself. X has got a 6 in front of it. How do you undo the 6?
Subtract 6.
But it's multiplying.
Oh, divide
Yes. So what does x equal?
4.
4. Good. And you gotta be careful because like you might think, oh, I'm done. I solved it. Like, no, you're not done. You found x. It didn't say to solve for x. It wants the total distance from C to E, which means that you need to find the distance from C to D, D to E, and then you can find the total distance. So the distance from C to D is 9x minus 7. You have the x value. Can you use that now to determine the length of CD?
Um, so that'd be like 9 times 4.
Yes.
Uh, 29.
Okay. What is the length of CE? No, sorry, not CE. BE. BE is the other way. So DE is this other length. What does that what is that length?
Um, 29.
Yeah, so it's 3x plus 7, which ends up being 29. Are you surprised that they're the same? No, because they're congruent. So what's the distance from C to E? Well, C to E is CD plus DE. What is the total distance?
68. Oh wait,
Right again?
yeah, 68.
Nope. Try again.
Oh, wait, 58.
There we go. 58. All right. Thoughts on that?
Mm, not really.
Okay. All right. So a new problem here. It's going to be related to the last one. Um, these two angles are congruent.
Okay.
But these two angles are congruent. You don't need to know why. I'm just telling you they're congruent. So we're going to set 6x plus 29 equal to 8x minus 5. This is another two-step equation. This is another problem like the last one where you have to move the variables around. Okay, so I want you to do that. Try solving this one. It's very much like the last one we did.
Okay.
How are you doing on this one?
I'm a little confused. Like I have 14x plus 29 equals -5.
Okay, so that's not, yeah, we're gonna have to adjust there. Always let me know. Say, hey, Matthew, I'm not getting in, I'm struggling. You always want to move smaller to larger. Okay, so which is smaller, 6x or 8x?
Oh, 6.
And so you subtract it. No, this is odd. It's like, why is the variable on the right? Well, it happens to be, right? So from here, it's a two-step equation. You're going to undo addition and subtraction on the right, then undo multiplication division or whichever whatever you see here. So keep going here. It's important that you try solving this one on your own, and then we're going to solve some more two-step equations together here.
Okay, I have x equals 17.
Okay, very good. All right. So now we're gonna look at some equations where the variables are on both sides of the equation. Okay. Just to kind of get better at this. So let's look at this one. 4y plus 26 equals 50 plus 6y. All right, so get this down in your paper there. The key is
Um,
to decide which way to move the variables. So when you're writing it down, you want to say, okay, where's the smaller variable? Is it the one on the left? Is it one on the right? You know, which one is it?
all right, so can you repeat that again? I was writing that down.
Yes, sorry, I just said I get so excited. When you're writing it down, try to look be like, all right, is 4y or 6y? Like, which way am I going to move it? Which one is smaller? Like trying to,
4.
yeah. So you're going to move that to the right. All right, so keep going from here. See if you can solve this, please.
I got y equals -12.
Okay, let's have you try one on your own here. All right, so go and see if you can solve this, please.
H equals 4.
All right. So one of the ways that we can check this is, or I can check this without actually doing the work, is just trying the number. 5 times 4 plus 3, that's 23. Does that equal 3 times 4 plus 11, which is 23? Yes, it does. Okay, let's have you try. So Sorry, I'm just trying to find another problem here for us to do. So let's look at the next one here. All right, so what is the number? What is the number in front of the negative r? Like, what's the number there?
-1,
So which is smaller, the -1 or the 2?
-1.
So this time you're going to move that over to the right. So sometimes you'll get one positive, one negative, or even both negative.
Okay.
So could you try solving this for us, please?
Mm-hmm. R equals 36.
Correct, good. All right. Let's take a look at one more here. See if you can work this one out, please.
S equals 7.
So when you add s to both sides, you get 3s minus 54 equals 21. But now you're going to add 54. So I get 3s equals 75. My guess is you maybe subtracted or did something different. Um,
Um, oh, oops, I didn't add 54 to 21.
okay. Oh, there you go. That makes sense. You divide by 3 and get s equals 25. All right. We do have to stop here for today. So I can see we probably